Hi everyone, today we will talk about the phenopropanoid metabolism in ripening fruit. It seems quite complicated, but it is very important, which can affect the property of the fruit. So, we will explain the metabolism in this presentation and hope you can understand. Here are our contents. We will follow this first step to demonstrate the metabolism and describe the effect.
First, I will talk about the general phenopeptide pathway. What are the phenopeptides? Phenopeptides are a group of compounds which consist of one aromatic phenol group and three carbon propentyl. Phenolene and tyrosine is the representative. So, how does the general phenopeptide pathway work? The pathway will start from phenolene. Phenolene can get from shikimate pathway, so was tyrosine. Then the phenolene can be converted to cinnamic acid by PAL. The cinnamic acid will continue to be catalyzed by C4H to form p-coumaric acid. Moreover, tyrosine can convert to p-coumaric acid through PAL. The last step, the p-coumaric acid will link with coenzyme A through the 4Cl to convert the 4-coumaric oil coenzyme A. The 4-coumaric oil coenzyme A is very important because it can produce other compounds involve monolinose pathway and the flavonoid pathway. Now I will talk about how does the 4-coumaric oil coenzyme A to convert linin and ligands. The 4-coumaric oil coenzyme A can convert to this acid coenzyme ACE, and this acid coenzyme ACE can convert by coenzyme A reductase and alcohol dehydrogenase to form its alcohol. Then this alcohol can polymerize to form linin and ligands, which is the end product of monolinose pathway. Here is the whole pathway of general phenopeptide and monolinose. Then Jia Haowen will introduce the flavonoid pathway.
After understanding the general phenopropanoid pathway, we know this pathway will lead to ligening and ligenin biosynthesis. Now, let's talk about the subsequent stage called flavonoid pathway, which will lead to flavonol and anthocyanins and other products.
First, we need to know what are flavonoids. Flavonoids are one of the most important secondary metabolites in plants. As the structure shows, flavonoids have the general structure of a 15-carbon skeleton, and these components contribute not only to the characteristic flavor and color, but also to protection for plant. During ripening period of fruit, the flavonoid pathway competes directly with general phenopropanoid pathway, and it composed of several branches producing flavonoids and other end products. But how does this pathway run? In the beginning, conjugate ring closure of charcoals result in flavonol. Then the central ring of flavonol is hydroxylized to dihydroflavonoids, which can be regarded as precursor of end products. Afterwards, the pathway falls into two branches. One leads to the dehydrogenation to form flavonols. In fruit, flavonoids are almost exclusively present as glucosides. They are almost abundant in skin and peel and decrease in concentration toward the central core. On the other hand, a specific enzyme catalyzes the formation of leucoanthocyanins, followed by the formation of proanthocyanins and anthocyanins. Those two products present different characteristics and functions. Proanthocyanins contribute astringent flavor to food and protect the fruits from predation, which often produce at early phase of the fruit development. As for anthocyanins, it generates the characteristic blue-purple reddish color in fruit and berries. More importantly, accumulation of anthocyanins only happens during the ripening period, so it can be used as mark of ripening. All those conversions occur in fruit cells and involve different enzymes, and those enzymes are loosely bound to endoplasmic reticulum. After synthesis, those end products will be transported to vacuum by specific transporter.
After beautifully explanation of the phenylpeptide pathway by our two handsome groupmates, now you may wondering what does this complicated pathway relate to our food ripening? Now follow me.
In my part, I mainly focus on the potential enzyme that related to the regulation of lignin in this pathway on the ripening fruit. There are several enzymes which are involved in this pathway that associate to the lignin regulation. They are PAL, CAD, and POD. PAL is the initial enzyme that transfers L-phenylalanine to trans-cinnamate. In some fruit, especially low-crud, develop increased level of lignin during storage, resulting in a fitness increase steady after harvest. The increase of lignin associated with the increase in PAL activities. In addition, lignin content of fresh tissue of fruit was enhanced by ethylene. The presence of ethylene is required not only for reducing synthesis of PAL, but probably also for maintaining its high activity. Tissue lignification may result in great fresh firmness, toughness of the texture, or loss of juiciness. CAD involved in the last step of the biosynthesis of monolignols. It plays an essential role in lignification, which is a conventional synthetic process in the food ripening. Studies show that severe changes in CAD activity have a striking effect on the composition of lignin. The strong lignification results thick helicarp of fruit. There are 4 stages in strawberry ripening: green, white, tawny, and red. Study found that CAD decreases after green stage and increases at the red stage. POD is an enzyme that involved in the last step of lignin formation. In tomato, POD may have a double role in restricting fruit expansion through cross-link of cell wall components and produce a protective barrier in the epidermis. This indicated that POD regulated cell wall, which leads to the cessation of fruit growth. There are several different performances of POD activities in case of undamaged and damaged pericarp in mangosteen. POD activity is not changed in the undamaged pericarp, but high POD activity were found when pericarp is damaged, resulting increased in lignin content and therefore increased firmness of damaged pericarp. In conclusion, phenylpeptides play an important role in plant growth and development. Several enzymes participate in monolignol biosynthesis have a potential for the maintenance of firmness. An integrated approach on lignin monolignol associated enzyme would provide a consistent modeling of lignification during food ripening.
Hello everyone, this is Wang Yue. So in the last part of this video, I will introduce the effect of metabolites in flavonoid pathway. Flavonoids as the main products of phenylpropanoids metabolism were studied a lot in the past few decades. These substances produced by flavonoid pathway mainly have 3 influences on fruits, which are colors, flavor, and disease resistance. The effect of flavonoid on colors is probably the most familiar to us. Anthocyanin is one of the most important pigments in plants. It is also the secondary metabolite of flavonoid pathway. Fruits with red, blue, or purple colors like berries, grapes, and blood orange all contain high level of anthocyanin content. That is because anthocyanin present different colors with different pH. It shows red color when the pH is around 7, while it is purple with pH between 7 and 8. When pH reaches 11 or even higher, the fruit is in blue color. Some of the flavonoids can help to create flavor in fruits. Although the flavor compound is very complicated and may consist of hundreds of chemical substances, the products or derived metabolites generated in flavonoid pathway can attribute to the flavor generation. For example, in the early stage of ripening, proanthocyanidin can confer strawberry astringent flavor. In addition, the flavonoids play an important role of tolerance to fungi during ripening. For example, Elva strawberry only display disease symptoms when it is at red stage. The immature fruits have high tolerance to fungi infections. This mainly owed to the flavonoid accumulation in the early stage of ripening. Proanthocyanidin, flavonols, and elagitannins largely produced by flavonoid pathway. They can strongly decrease the absence of pathogens during ripening. In conclusion, the phenylpropanoid metabolism is a very complex process which runs through the ripening of fruits. This video mainly focuses on the two pathways of the metabolism, general and the flavonoid pathway. The metabolites of these two pathways, lignin and a series of flavonoids, have great influence on colors, flavors, textures, and the disease resistance of fruits. So thank you for watching this video, and please feel free to ask questions.